It's my great pleasure to introduce some very smart people from New York. I would ask them to turn on their microphones and their video. Ray, Alan, and Wendy to SumSF, thank you so much for being here on behalf of Jeff, the chair, as well. And I'm going to let you all self-introduce and take it from there. Thanks.
Yeah, thank you. Okay, I want to welcome you to the UNUM project, which is an NSF-sponsored project, Unification for Underground Resilience Measures. We are, Professor Deborah Lafer is the principal investigator. I am the co-principal investigator and also a research professor at NYU Wagner after many years as a full-time faculty member. Joining me are Al Leidner and Wendy Dorf of GISMO, and our research partners, which are our research partners. And I want to thank Peter Gamosh and the rest of the team for helping out in this presentation. Yesterday and today, well, yesterday, we're all familiar with the stringing infrastructure above ground, often clouding our view, but much of it is today under below ground, and as such engages many, many stakeholders, some of which you see on this picture. And that is the theme of our presentation. How do we get everybody together to deal with the underground? Briefly, our project occurred in 2 stages. We were funded last spring by NSF to develop 2 pilot sites, and I'll show those in a minute, build a stakeholder network, engaged over 40 who were asset holders and community people, applied for a stage 2 NSF project, which we were awarded, and then stage 2, diving much more deeply into data integration, stakeholder focus group surveys, artwork, workshops, a digital twin, GIS, and many more. The MUDDI Standards Working Group, which you'll hear more about, helped us pilot interoperability of many different utility data sources and designing a roadmap. And we've done continued stakeholder engagement throughout stage 2. The New York City pilot areas, which we have chosen, the Grand Central study area around Grand Central called Midtown East, and Sunset Park in Brooklyn. And these 2 areas are very far apart in terms of the demographics, the diversity of the populations and the economic base, as well as the kinds of underground infrastructure problems that they have experienced. And the pictures below are for that, for those areas. We are faced with an enormous underground infrastructure, which I'm sure many of the attendees are familiar with. But what is very unusual is these are very interconnected. On one side, you see electrical and wastewater pipes intertwined. On the other side, the lower part, you see the full range of underground infrastructures, at least geographically interconnected and often functionally. In the middle, you have what you see on the street very often, which are the multiple codes for telling you where different infrastructures are down below. And there are multiple points of failure. These are actual cases where water drainage and street substructure are combined and caused a massive sinkhole, and then water supply lines and street substructure as well, points of failure due to interconnections. Next. And what illustrates this in a tremendous way are the effects on the underground infrastructure of Hurricane Sandy in 2012. I know this is often brought up by many people, but the underground is really quite incredible. These are pictures from the Metropolitan Transportation Agency in New York, how the line A, the Cranberry Tunnel on the AC line, was completely flooded. Then they began to fix things, fix the track above ground. But what you have to remember is that many of the above ground lines are connected to the below ground tunnel system. And finally, the electrical system, Hurricane Sandy once again. And you see that this is the 14th Street power plant and substation went up in flames. Very prone to flooding, or very low elevation, and connected to a lot of the underground electrical wiring. And now I would like to hand over the presentation to Al Leidner.
Okay, thank you very much, Ray. I'm Al Leidner. I'm a former GIS director of New York City, worked for New York City for 35 years, a lot of that with Wendy Dorf, who will be speaking next. And both Wendy and I have been pretty persistent pursuing the mapping of underground infrastructure since 9/11. But this particular UNUM project, for which we got the NSF grant, basically has us addressing emergencies and disasters that are related to underground infrastructure. So emergencies might be characterized as somewhat localized and smaller kinds of accidents and damages, while disasters, as you all well know, are pretty wide-ranging, cover a lot of area, cause a lot of very expensive destruction. These are only partial listings. And frankly, I think here in New York City, we've experienced all of these, but perhaps not an earthquake like some other regions. So again, the focus or the use case that we're addressing is emergency response and disaster planning and response, as you see on the right column. Although in other work that we're doing to map the underground, we're also looking at other use cases like excavations for new foundations, maintenance, smart cities, digital twin, and so forth. And of course, in terms of the kinds of data we're most focused on, it's the utility networks and their features and their attributes that you see in the left column. We've done work over the years to try to identify who has what data. And actually in New York City, there's a fair amount of data. New York City itself, for the utility systems it manages, does have very good data, but the sharing of that data, as you see on the right-hand column, is very limited. For the private utilities, Con Edison and National Grid and Verizon as examples of that, we are not really knowledgeable about the depth of their data or the form of their data. And we know other than the 811 street markup system, there's very little sharing of that data. So basically, all that underground infrastructure data is within silos that are rarely, if ever, brought together, and that causes many problems, which I'm sure you've discussed in previous sessions. So this is what we conceive of as what we would ultimately like the data to show us. In 3D, all the different layers registered to a common base map and to a common horizontal and vertical datum, so that we can see the interdependencies and the conflicts and the risks and the threats and the possibilities for cascading effects. And we are starting to see more and more of this. We knew, again, through our relationship with subsurface urban utility engineering, we see that this is being done on a very focused basis. And what we're trying to do on the GIS side is extend this across entire networks, all connected together and related to one another. So how are we going to try to do this? Is the first step that we've done, and we've been working on this for many years, has been through the development of an enterprise GIS system in New York, including the creation of the city's Basemap, and then gone on to the MUDDI model, working with the Open Geospatial Consortium and many other countries, actually, to develop a data model that would encompass everything that's underground And then that goes on to, once we get that data, the ability to do smart cities and digital twin kinds of mappings and analytics. I'd like now to introduce Wendy Dorf, who will speak about the development of the GIS Basemap in New York and also its application during 9/11. Wendy?
Okay, good afternoon. My name is Wendy Dorf. I serve on the GISMO Board of Directors. I was employed by the government, New York City government, for 35 years, more than 20 in DEP, where I managed digital mapping projects for over 20 years. The first project was the conversion of citywide water main paper maps into GDS CAD format. I'm going to give you a little background of how we got to the base map and how that over the years grew into other things and brought us to where we are now with the UNUM project. The water supply map was near completion when DEP funded the development of the citywide New York City base map in Esri. The base map provided a locationally accurate platform, including block, lot, street, buildings, and photogrammetry of the entire city. Over the years, most agencies have contributed their data, much of which is open data, to the base map. Subsequently, the sewer paper maps were converted into Esri GIS format. Shortly thereafter, GDS CAD water main maps also were converted to an Esri platform as well. The Esri water main and sewer map layers were integrated into the base map, demonstrating the ability to use cities' cadastral map data for underground mapping as well. This is the GIS map request intake and pickup station. Within hours of the World Trade Center attack, an interim site was equipped to respond to the emergency. 1 week later, the Emergency Operations Center moved permanently to Pier 92. The emergency mapping and data center, as seen in the photo, was set up to respond to map requests. The map grid of the site was developed by the Fire Department of New York to enable first responders to navigate the site safely. Further, the maps were developed to advise citizens of street closing and outages of utilities. Maps were submitted to the media and newspapers with daily updates of these conditions for citizens. Thousands of maps were created and distributed within a 6-week period. Many of the mapping specialists who volunteered were GISMO members. The operation was nonstop for more than 18 hours a day for 3 months. At the Emergency Mapping and Data Center at Pier 92, I managed a team of civil engineers and GIS specialists named the Deep Infrastructure Group, or DIG. The team digitized data of the World Trade Center site provided by infrastructure agencies and utilities. The digitized maps enabled first responders to navigate the site and bypass voids. The data was submitted in a variety of formats and media, including Mylar, paper. Some were digitized. The sharing of data in response to the emergency demonstrated the value of data sharing. It was very difficult to collect all this data, and I think for myself, from that point on, it's been a mission to try to have that happen. So we're very pleased to be working with NYU to show how that can be done. The mapping combination of photogrammetry and LiDAR overlaying the grid revealed the location of fires burning underground. Freon becomes a poisonous gas when heated. Locating the tanks underground enabled safe removal of the Freon from the tank and safe removal of the tank itself, preventing a loss of life of workers on the site and residents in surrounding areas. This is a premier example of the value of understanding the underground and of GIS in locating what is actually there.
Okay, so I'll pick it up. You know, as a result of our experience with 9/11, we developed a vision, Wendy and myself and others in our community, for how we wanted to deal with underground data, which we understood as a result of 9/11 to be absolutely essential for dealing with so many things, particularly disasters. And so very similar to the base map that we created that integrated all the surface features and all the surface location identifiers, what we wanted to do was relate that to all the layers of underground infrastructure so that we could see all the underground infrastructure in accurate relationship to each other and to the surface and to the built environment and to the natural environment. that we are doing with the enterprise system. So I think a couple of more clicks will show you all the different kinds of data associated with the different kinds of utilities, which now, or hopefully in the near future, can all be interrelated. So we're really talking about an enterprise GIS utility of everything in the city that will really comprise thousands of layers of information that can be combined in any combination necessary to solve a problem or to support a field operation. We've been fortunate to be working with the Open Geospatial Consortium on developing the data model for such an integration, because the data is all over the place. Everyone, as Wendy described, bringing the data together during 9/11 was practically impossible. It took us weeks to do because everything was in a different format. No one was used to working with each other. So now with the Open Geospatial Consortium, with the support and help of the American Society of Civil Engineers, who we've worked very closely with, and with the Ordnance Survey of Great Britain, Scotland, Denmark, Flanders, Netherlands, Singapore, and a number of other countries, actually, we've combined the best knowledge and the work done already of these organizations and nations and developed the MUDDI model, which we feel is very comprehensive, describing all the key features related to what is underground. So in the center are the network features. You would know it as cables and pipes and valves and meters, the stuff that carries the flow of utility services. Going down, you see, and each one of those features has attributes. And if you go a little to the lower right, you see, and all of them pretty much have accessory features. Going up from there to the environment, we know all that is underground is surrounded by an environment that includes soil and bedrock, water flows, remnants, basements, foundations, chemical contaminants. It's a very complex environment in constant flux. So that's another important example or part of this. Then all that gets worked up to the utility networks themselves, which GIS handles very nicely because of it connects everything together. And then that can be described by various areas of interest: catchment areas, service districts, utility subnetworks, preservation districts, and that list can go on and on. So this is a very conceptual picture of all the things we're trying to capture and integrate through the MUDDI model. Okay, so one of the very interesting things that we've discovered, particularly in our work with the American Society of Civil Engineers and MUDDI and GIS, and in our understanding of CAD and of construction work, and also of BIM, is that the entire built environment, above ground and below ground, all needs data from its various components along the line of its life cycle. So GIS contributes data to SUE, SUE contributes data to GIS. They both contribute data to CAD, and all of them contribute to BIM and to digital twins and to smart cities. So we understand this as a total data environment, and with everyone making contributions. And so the setting of standards and the creation of the ability to interoperate is key to this. We see this holistically. So we hope this is the direction we're all heading in. And I'm very glad to report that, and we have Karsten Runsdorf of the Ordnance Survey on this call with us. I'm not sure we have Neil Bramall, but they've been key to getting the UK to actually say, we're adopting the MUDDI model, we're going to modify it for our own particular use case, and we are going to map the underground infrastructure of the entire UK within a matter of a couple of years. And this is just an enormous validation of the work that so many people have done for so long, including Jeff Zeiss, who's key to this particular program. And we hope it gives inspiration to the United States and to New York City to keep on plugging away at doing this, following the lead of the UK, but also of those countries that have used the INSPIRE data model in Europe, Scotland, Denmark, Flanders, Netherlands, and Singapore, to forge their own path in this direction. So we're very optimistic that we'll be able to do this, especially with the continued work on the UNUM project, which will fill in some gaps, and with the continuing work of the Open Geospatial Consortium, which is now focusing on the environmental underground environment aspects, which is Andrew Hughes is leading that particular effort. Okay, and I will now give it back to Ray to finish the presentation. Ray?
Okay, thank you, Al and Wendy. The third major methodological orientation of the project is a digital twin. And that work involves working with the Chinese American Planning Council, which is a New York City social service organization. And it's a real co-production of this digital twin reflecting community concerns, where the community comes and actually identifies where their problem areas are on a map. And then once that's done, it can, it's on the map, we know where it is, these are some examples of using the digital twin. If you plant trees in a neighborhood, the community can identify the conditions of the trees. Local flooding is really the most popular use of the digital twin, where you can actually have the community go in and identify where they're experiencing flooding so that the city knows. And another major component of the project is experiential art. We have an artist working very closely with us who is actually putting together an installation, if you will, where people can actually experience what is going on in the area. It's an interactive research station, if you will, and it's focusing on the underground within a concrete catch basin that the public can view. It's critical to understand that stakeholder engagement and involvement is critical to our project. Here is a somewhat of a spaghetti picture, if you will, showing all of the different groups that are attached in some way or another to the UNUM project. Next slide. So we've kind of structured this a little bit in that the core team interacts with state, local, citywide agencies, federal. These solid lines are fairly well-established relationships, and the dotted ones are ones that we're moving forward with. And again, OGC, GISMO, very strongly attached to the core team, and the utilities as well, across electric, gas, steam, telecom, water, wastewater, and transportation. And this is really a first that we've been able to accomplish in bringing together a very close-knit group. And we're running focus groups to be able to have the stakeholders provide specific input into our project. We held 2 in February, 15 participated from the gamut of reps of government agencies, communities, elected officials, utilities, and again, trying to get feedback. And we're going to use the feedback as the basis of a much more extensive survey. And so the key theme here is of the focus groups, that people want to understand cascading infrastructure failures and community impacts from the underground, collaborate during non-emergency times, avoid the loss of institutional knowledge as people, there's a large turnover of people in many of these stakeholder organizations, and finally, improve communication among stakeholders. And there are many conclusions here. People really regard underground infrastructure mapping and data integration is very important for the resilience, integrity of the infrastructure. Emergencies and disasters are often linked to environmental conditions. Asset holder communities are at various stages of moving away from their legacy systems. And finally, we're trying to integrate 60 or more open data layers from federal, state, city sources with the help of the project's research assistants, which has the added benefit of educating them. And there are many benefits here: increasing safety, decreased management costs, improving communication services, and promoting resilient systems in the face of climate change, and developing models potentially transferable and scalable to other areas. We want to thank the NSF for funding our project. That's the name of it. Deborah is the PI, and I am the co-PI, and there are UNUM and GISMO team members and stakeholders, which we also acknowledge. And we have a disclaimer that it's all our fault. And we have a project website, email, and an email, and there's an NSF fact sheet as well, where you can get additional information. And then we've been well at work, very much at work, producing, disseminating our work at a variety of public forums, professional organizations, academic institutions, and the like. Thank you. And with that, open to questions. And I believe there have been quite a few already having to do with how reliable the records are, and the willingness to share, and that we're working on, the willingness to share. Reliability, you know, we're trying. I think even the utilities find that challenging, and we're trying to share in the sense of having a data pilot and also putting a lot of the open data in one place. And we're starting with a pilot and hoping this provides a platform foundation for a larger effort. Al, Wendy, you may want to try.
Yeah. Well, yeah, we had a questionnaire that we gave to the utilities and the infrastructure agencies that have the data to get some idea of what they actually have, if it's even digitized, paper, or whatever it is. And actually, we've gotten some responses, and it's certainly a long way from what I recall was going on when we were at the World Trade Center. They're getting younger people, and more of this stuff is becoming digital. And we're working on issues of security, because that has always been a problem in collecting data. But we also have a very good team looking over the work that they have. We have professors, people from OGC, and they're going to help us with the technical part to make sure, you know, that the data is good, and put it together in some format that integrates. It's going to take some time, but we really feel like we're on the right path.
And what I'll throw in is that we are aware that the data from utilities and even from city agencies is what ASCE 38 would characterize as quality level D. It's based on drawings, often design drawings. We are trying to build in a mechanism by which the accuracy of those drawings and the map that will be steadily and consistently improved with every excavation. And we know in New York, there's as many as 200,000 excavations annually, and we hope to be able to tap that data or collect data from those excavations to make the utility data more accurate.
And there were a number of other specific questions about the digital twin going subsurface. Were very interesting question, and we're hoping that we can expand to that.
A second question here is, how willing are network owners in New York City to share underground data? I think there's a willingness. There was a fear, I think, an enormous fear on the part of the utilities that their private data would be made public. There are competitive concerns about that. There's also safety concerns. And so we have spent a lot of time working out a non-disclosure agreement that would keep their data safe, but also allow the data to be shared for operational reasons. You know, when there is an accident or a disaster or emergency, that data would be shared, but very, very securely. So I think once we get that NDA out, I think everyone will be assured and will be able to share that data.
And also, will the UNUM be publicly available? I would say that the data that we're using from open databases will, but the pilot to build a framework can't be. Al, Wendy, you may want to.
Yeah, I would say, look, at this point, we've actually identified 60 open data sets that give a pretty good idea about where everything is. And that is going to be made public and will greatly facilitate the way we interact with the community. The detailed utility data to the inch or to, within a foot plus or minus, that is something which the utilities themselves, including the city agencies, are very reluctant to just open up and share. So we are going to try to find a way to sort of give the community a sense of the data without actually showing them the precise data. And that, I think, will probably satisfy the communities. At least that's our hope.
I think with the twin, they're also starting to learn what to be looking for as they walk around, to give them a clue of what may be underground. Okay, just some generic stuff that any one of us could actually look at without a problem, and it's important for them to know, because especially in New York City, the base level of politics is through community boards, and community boards are involved in capital projects. And they've always been like, they have flooding and all these problems. They can't have a bathroom in a park. They don't know what's going on. And some of this, the focus group working with the community and giving them some information as to what to look for to get an idea of what your problems are is a very big part of the project as well. In terms of the underground data itself, probably at least at this point, and we have to be keeping that secure, but there'll be enough open data available for the community to feel very comfortable. And there's a lot more than we anticipated ourselves, to tell you the truth. Much, much more than when I was working at DEP, sewer and water information. And so they have a lot to work with as well.
And then there's Occupy Sandy. I'm not sure we've gotten that specific, but that's an very interesting question.
Well, I see something here also about we're considering infrastructure on private property. I think, what we do have, I think what the city does mostly is that we'll have like lines that go into houses. And I think, with the water and sewer, but I don't know to what extent we're going to be really at this point involved on that level.
If I could comment here, to the extent that big transmission lines run under properties and subways run under private property, yes, we'll be doing that. And so, yeah, we will get the private property utility data to the extent we can. Because it's of great interest, especially when you're excavating. As far as the pilot database goes, yes, our objective in UNUM is to use the MUDDI model to build a database based on the data that the utilities actually have, which is a lot smaller than the MUDDI data model, but you can only start with the data that they have in hand. So that's what we start with, and we hope to build that out.
I mean, part of the project really is to make it sustainable, and actually, hopefully, the model will be slowly, in New York City at least, through maybe the bids, the building. There are bids, 59 bids throughout the city, and the digital twin is working with a bid, and we're hoping that is a model to pass along on the community side. And hopefully, with future funds, if the project turns out the way we hope it will, this really could be a model beyond New York City as well. We're very excited about it.
You know,
yeah.
Ray, maybe you
Oh.
want to answer the next one because it talks about how are you training
Mhm.
students to use CAD and other digital tools to fill the green jobs of the future.
Yeah. I was going to say that too.
Go, Ray. How are you integrated in managing the life cycle of natural and built infrastructure?
Oh, yeah.
The engineers, biologists, ecological advocates contributing to digital twins is cool. How are you training students to use CAD and other digital tools to fill the green jobs of the future?
Well, I think certainly the first part, we're looking into that. That would be the next step. The digital twin is not quite that ambitious yet, but it certainly has the structure to allow that kind of life cycle, natural and built infrastructure in it. And training the students, very definitely. CAD is only one type of tool, but they're definitely getting their fill of training to do a lot of this work.
And that's at the university itself. But there
Yeah.
are also high school students
we're
that are
doing
going to
high
be
school as
introduced to
well.
some of this. Maybe not on
Absolutely.
that level, but if that we grab them, they may then be interested in going forward in it in a career.
Exactly.
Uh,
Yeah, and I just want to point out the students are using Bentley products to do 3D.
Yeah.
Peter reminded me of that.
Right.
Thank you. Good
Thank you,
point.
Peter.
Yeah, thank you very much.
Thank you
Okay.
very much for having us.
Yeah, thank you to Jeff for bringing this together. It was fantastic.